Hey guys, how are you?
I'm doing well. How are you?
Great first session. Enjoyed it.
Yeah. No, that keynote was excellent. That was excellent. So let's go ahead and open this up. So everyone, thank you for joining. We are going to hop directly into our first panel discussion for the day. I'm here with Ramesh and Abhilash, and we're going to be discussing the adoption of serverless at scale. So I want to go ahead and encourage everyone, please hop into Philo and ask your questions. If you have questions about adoption of serverless at scale, CICD, really any of that sort of stuff, go ahead and pop it in there and we'll have those sent over to us. We're going to forego any kind of long introductions and get directly into questions now. So friendly reminder, please, ask questions. The more you put in, the more you'll get out. So with that being said, I think we're going to go to a question to Ramesh first, which is, Ramesh, sir, as an application development specialist at Azure, what recommendations would you make to speed up migration from on-premises to cloud?
Sure. Hey, thank you, Micah. And again, welcome all. That was a great kickoff session we all witnessed. So yeah, I hope you will take away a lot of valuable stuff from this panel discussion too. But yeah, coming to how to accelerate the cloud migrations, right? So again, I've been in this industry, in the cloud, especially in the cloud industry for almost 10 years. I've worked with multiple cloud platforms, right? It doesn't matter which platform you again work with. Let me share my maybe screen, that way I can put some context. Let me know if you can see my screen.
I can see it, sir.
Awesome. So again, when it comes to cloud migrations, right, here we are talking about mass migrations or large migrations, right? So there should be some kind of business event that would trigger these migrations, right? That's the important thing, because there has to be a good business reason why you want to adopt the cloud, because cloud brings a lot of value and a lot of variance. But we just want to make sure actually you as a company, you just pick what is that business need you are trying to solve for your customers or for your business, right? It could be maybe data center expiration, it could be app innovation or modernization, or maybe some capacity needs. So once you figure out actually what is that business need, right? So the next important thing is really a methodology, right? So a methodology that you partner with your cloud platform, be it Microsoft Azure or whether it's AWS or GCP, every cloud platform has a methodology. It's called Cloud Adoption Framework, CAF, right? Because after we did so many migrations and worked with thousands of customers, right, we kind of gathered all the best practices and we packaged them into a framework called CAF. Every cloud provider has this framework, right? You have to adopt this framework instead of you reinventing the wheel by yourself, or instead of you coming up with your own process. Just rely on the cloud platform and they bring this framework and they bring this expertise to you to really accelerate your migrations. So really, like, I want to quickly maybe spend quickly a minute on this CAF framework, because this is very general framework that any platform will bring to you. But mainly the key, most important thing, what I have seen from my experience, is you got to have an executive sponsorship. You got to have your leadership buy-in for this cloud migration, and have that ownership identified and have those roles and responsibilities within that leadership identified. Who will partner with the cloud platform team, and who will partner with, if you are using any partner, like an ISV partner in this case. So you got to really make sure all those players are lined up and you have that executive sponsorship. That's the first thing that needs to happen to these migrations. And the second thing is, the cloud platform teams, they bring a lot of these assessment tools, because we call this portfolio assessment. So just to make sure we have a lot of these free tools that they bring to the table, just to deploy in your environment, so that you can assess your environment and you can assess the portfolio to identify what are the candidates for best fit for the cloud migration, whether it's just lift and shift, or the modernize, or re-platform, or re-architect. So these tools will give you those outputs, really. So using those outputs and using those insights, you plan what kind of waves you want to really put, and what kind of dependencies are there, what applications can go independently, and what applications have to go together. So all that really comes out of this assessment. because Azure has, again, they have their own assessment tools. Even AWS have TSO logic or application discovery. So they have a lot of these free tools. So please make use of those tools to really come with that portfolio assessment to make those migrations easy and also accelerate. And then the next thing is really getting your people ready, right? You have to get your people certified or skilled on these platforms. Whatever the cloud platform you are adopting, you just want to make sure your resources are ready to going through some certifications. And the last thing is execution. Again, there are some proven methodologies like re-platform, re-architect methodologies, and containerization and serverless, which we are talking today. So just make sure you pick a right pattern and right migration path to migrate these. And of course, governance and management is the pillars. You put all the way from idea all the way to the production. You just want to make sure there is a governance framework built in. So if you follow this CAF framework, I think you will be golden, and your accelerations will, your cloud migrations will go much faster and smoother.
Yeah, excellent. I mean, you mentioned governance, right? Which is really important to me when I'm working with new teams. I'm often saying, set your standards early, right? If you're moving to the cloud, especially serverless or really anything, it's a green field, and it's an opportunity to really set your standards and to figure out how to make people follow those standards. And governance is probably one of the biggest kind of success markers I see of people trying to move into the cloud. All right. Well, thank you very much for that. Let's see. I've got a question here for Abhilash. Abhilash, let's see. When dealing with various maturity levels of teams developing using serverless technologies, what is one advice that you can give to those who are on that journey?
Thanks, Micah. That's a great question, right? So just to give you a bit of background on, the experiences that kind of shape my thinking on this topic, right? So regarding the teams of different maturity levels, right? So I've been fortunate enough to have had the opportunity to work with, a unique intersection of clients in the BFSI domain. On one end, it's Fortune 100 companies, well-known banks, insurance companies, that have been around for a very long time. And I have also had the chance to work with fintech startups, right? Who are hoping to actually disrupt, some of these incumbents in this space, right? So in contrast, you have organizations on one end which are very mature, with a very diverse IT landscape. Basically, everything from mainframe monoliths to serverless microservices, representing every significant architecture or technology paradigm shift that has happened in the past few decades, right? And on the other hand, you have very lean organizations doing very greenfield cloud native implementations with no legacy baggage, to speak of. So varied use cases, but still there are some common themes and learnings and recommendations that emerge out of this, right? So we can probably start off by looking at, how a typical serverless adoption, journey is, followed by some of the challenges that the teams face, and then, probably discuss some of the approaches that could be employed to actually, make the situation better. So as we all know, serverless has a very low barrier of entry, right? So what do I mean by that? So most companies experiment with a typical adoption pattern that starts with, including some initial piloting with, function as a service, right? Which is still the most overwhelming representation of serverless computing out there, right? As an extension of their existing compute workloads, which may be running in, virtual machines or containers. And these type of workloads usually tend to be pretty simple, right? Mostly standalone, very less complexity, asynchronous, mostly doing some transformation stuff on the side. So these pilots are pretty successful, right? It's pretty simple to write, a very scalable function or a backend in any of the, three or any of the public cloud providers without a lot of thought about the underlying infrastructure, right? For simple workloads. But over a period of time, the service adoption grows further within the enterprise, and you gradually look beyond functions to a more wider set of services, encompassing workflows, messaging, notifications, databases, stream processing, edge computing, and so on, right? And that's where the complexity starts, creeping into your ecosystem, right? Even though the initial stuff, the adoption has been like in the form of a evaluation of some pilot workloads, very soon teams have migrated into the serverless approach of building everything using serverless, right? End-to-end application using serverless solutions. And this change in adoption pattern happens fairly quick, right? But oftentimes what happens is this adoption has happened without a corresponding improvement in maturity on the application design, implementation, and the operational aspect critically, which leads to many difficulties down the line, right? So that's the adoption pattern that we've seen. So what are the typical challenges that we see with respect to this kind of adoption pattern, right? Difficulty with scaling and operating reliably at scale, right? So basically, there are a class of issues that only come when you are, exposed to a certain scale, right? The APIs and functions are not typically designed or implemented to be idempotent, right? So with typical scalability issues, you will find all these kind of connectivity errors and timeouts and stuff. And then you might have, your functions and backends getting executed more than once, and they're not designed or implemented to be executed multiple times. Then there is, over-reliance on synchronous communication methods instead of asynchronously. So there are no buffers really in your architecture to actually, compensate for the increased volumes and issues that you see. Very low resiliency to failures, dependency on strongly consistent data models versus eventual consistency, because you're still taking a lot of the learnings that you've had, from on-prem and the previous, implementation and moving it into the cloud. And also all these issues are fairly compounded if you're going to be integrating with some legacy applications, right? Which might be running on-prem. They don't have the same, scalability and elasticity that you'd find with, cloud native applications. And then there are operational difficulties, right? So distributed applications are very hard, right? We all know that. Serverless apps are harder still. And I feel, the granularity of the service is one of the contributing factors, right? Which itself is not really a problem, but then this whole trend of creating microservices and then, getting exaggerated into nano services, so to speak, under serverless has created all these issues, right? All these calls that happen are usually like, this orchestration of multiple calls that are happening behind the scenes across multiple gateways and databases and queues and stuff. Where it's fine when things are going fine, but then once you start having issues and stuff, it's very, very hard to troubleshoot, right? Most function executions happen in a very short time period, and due to all the orchestrations, it's very easy to lose track and of the flow, and troubleshooting and pinpointing errors, it becomes a major exercise, right? The last major factor that we see is also around tooling, right? I mean, you've seen it in various surveys and stuff that have been conducted by different vendors and stuff. The serverless world has been, evolving pretty rapidly, right? There's a bit of fragmentation, understandably so, on the ecosystem when it comes to the tools, right? I mean, there are only a few options when it comes to having a complete integrated end-to-end lifecycle tools, right? It's usually what we have seen. Enterprises end up, stringing together multiple open source and commercial solutions and augment it with capabilities provided by the cloud platform itself, right? So you're using a variety of tools, so which requires a bit of evaluation, planning, forethought, and making sure you have the right tools so that you can be successful when this model becoming mainstream, right? Of course, there are other challenges too, like security, lock-in, lack of automation and stuff, but these are the things that we see predominantly. So talking about the challenges, now, what is the model that, we could use or adopt to actually make this a bit more easier, right? So essentially, the model that would propose is the same as what you would do when you're adopting, cloud migration, right? Or you're embarking on a journey towards, adopting cloud or cloud first sort of a mentality, right? Start small to begin with, get familiar with the platform capabilities, the various tools in the ecosystem, experiment with, prototypes, build the foundational capabilities, build some reusable, software components that basically encompass the architecture decisions, compliance, and security policies, which you can then distribute across the team for uniformity. Focus on high automation and security. Very, very important. Observability is another aspect of the application, which has to be there from day one. And then build a set of reference architecture implementation. So at creating this paved path for the teams that follow, so that they don't have to do a lot of experimentation, right? And then you basically iterate from there, right? Design and implement the gaps that you identify with the initial workloads, and harden the foundational capabilities, right? So over a period of time, you reach a certain level of maturity. Once your operational and the development teams are fairly confident, that's when you can pivot towards a serverless first sort of a mentality and then be successful there. So essentially, that's my recommendation when it comes to looking at this problem. I'm sure I might have missed a few points, but then what do you guys think? Do they resonate with what you guys have seen and observed in your work areas? And maybe Micah, if you can share some of the experiences that you've had with serverless adoption in Asurion, I think that would be awesome.
Yeah, absolutely. You hit on a concept that we talk about quite a bit, which is like a paved road solution. I think the first time I heard about that was from Netflix some years ago, and it's about finding repeatable patterns. And people, we've got some questions about, what does success kind of look like, and how is serverless? How have you been successful with serverless? And so, like for me, at Asurion, like just to call out, like what serverless has done for us right off the bat, we've definitely realized and can absolutely attest to like the immediate benefits that you hear about when people talk about migrating to serverless, like cost reduction. You're only paying for what you use, so the vast majority of the time serverless ends up being cheaper. Of course, there's obvious things with security. We're not talking about a patching cycle. We're not doing SSH key management or user access controls in the same way that we were. And it does, of course, speed up our time to product delivery, because serverless can be used from everything from our smaller proof of concept applications to our large scale apps, and we can stand up and operationalize our applications very quickly. But really, I think, in my opinion, the biggest wins of serverless come out of embracing the entire serverless ecosystem, including both the principles and the tools that make it up. So like when we're designing new architectures or we're trying to solve new problems, we actually have ready-made products that are backed by these really great serverless principles to accomplish whatever it is that we're actually trying to do. Our cloud provider is saying, hey, you want to do X, Y, or Z? Here are all of the tools you need. You can do it with these tools. And then we're able to do research. We're able to join that kind of global community and culture about, how do we solve these problems? And there's a ton of examples and documentation online for how to utilize these tools properly. And then as we continue in our serverless journey, these principles of serverless became more understood and kind of got more ingrained into our regular problem solving. And this led to a change in mindset of developers and ultimately a maturation of the applications that we build. So we for starters, developers no longer are focusing time on writing boilerplate code and instead focus on business logic, right? That's a big win. Boilerplate code is zero value add work, right? We want to eliminate it. What we found is that developers that embrace these concepts and become more focused on how serverless components work together and like why they work the way that they do, the mind state changes and suddenly some operational aspects start to creep in, and essentially developers start to think a little bit more like traditional ops in a way about how is this going to operate. Things like runtime limitations in Lambda or application dependency considerations become topics that are constantly we're constantly having these discussions around, and this results in a basic reduction in I think something everybody's seen before, which is like the throw code over the fence mentality, right? Like the old school kind of developer mentality that used to exist sometimes. It was, I write code, QA handles it, while it's on its way to production. Once it's in prod, ooh, that's ops problem. And part of the reduction in that is because the runtime accountability is now shared by development and operations. The code you write kind of also because we're doing the language of AWS, which I really liked from the keynote, all of that stuff is that runtime is now built in, and those considerations happen when you're architecting the application. And so no one manages the runtime, right? It's serverless. We don't have to manage it, but we're still accountable for how the application behaves and how our code executes. And the way that it executes through serverless is that serverless is very principled. So as you end up becoming more familiar with serverless concepts, your application design can actually mature. And so, serverless is built on concepts like statelessness. It has modular and loosely coupled components, and it favors an event-driven design. So as you learn these principles and you then have developers that continue to iterate on what makes these applications successful, it leads to further advancements. Things like asynchronous processing that we were hearing about from the keynote, data flow and data integrity improvements, different application optimizations. And then like we've gotten to a place at Asurion where, this has even led to us doing like a distributed UI, where we use serverless as a backbone, but we have a dozen or more teams that are independently hosting their own like JavaScript components, which we can stitch together for like a seamless end user experience. And I know that's kind of not like a one-to-one, but in my opinion, if it weren't for serverless and distributed applications, I don't think we or the community would have necessarily gotten to something like a distributed UI, which is just pretty exciting to me. And then just a couple other wins that I want to share is, serverless does do an excellent job of creating culture. And this happens on a couple different levels. It's like the global level and the local level. Global being the entire serverless community, and local being, at your company or who you work with. And so this does help us attract talent, because you want people that are excited about technology, and that good talent is going to follow what's very new, what's very cutting edge, what excites them. And you're going to join that global culture and benefit from the larger serverless community. We get a shared vocabulary, which allows us to even sit here on the Zoom, be able to talk about Azure and GCP and AWS, and we're talking about serverless, but the actual implementations and specific tooling isn't really what matters, right? All of these things follow very similar principles. And we're able to build off the success of both those local and those global communities, which of course aren't mutually exclusive, right? Like if I'm working at Asurion where I work, and somebody is doing something really cool with serverless, odds are that the origin of that idea, or maybe somewhere up the chain, that was taken or borrowed from part of that global culture. And then we can look for those repeatable patterns, and we can offer new innovations and efficiencies. So what do you all have any further thoughts on some of the benefits of serverless that you've noticed?
So in terms of, especially in the startup world, right, where there's a lot of focus on, innovating and getting it out and putting it out on the market, right, beating the competition. From that standpoint, I think it's a clear differentiator, right? You're really, really focused on building your application and setting it up to be successful, so that, when that big, sort of lightning strike happens, if you're lucky, you are not struggling to actually scale, right? So there are a lot of benefits there. We see one of the primary motivators why those companies are adopting it, and the agility, right, of the tools. The maturity of the tool set is not yet there, but still it hasn't stopped anyone from really going down that road. So definitely agree with that point.
All right, great. Let's see, we've got a question. We've got people that want to know more about CICD tooling and visibility into our serverless apps. Would we have a volunteer to kick off that conversation for us?
Sure. Yeah. So observability is one of the aspects that I had mentioned as one of the the points that often leads to issues with serverless, or not the implementations that are not that mature, right? So it's basically not only about just logging data and then building some sort of a dashboard or something on top of it and trying to understand what is really happening, right? You need a more of a holistic view when it comes to looking at your application and its dependencies, and trying to understand what are the key metrics that you're trying to target and track, and then being able to look at and zoom in into any aspects of your applications and have enough data to actually go and evaluate the health of the application, right? And being able to do that reliably at scale. So that's a very, very important part of being successful in the serverless domain. There are quite a bit of tooling around it, open source as well as commercial stuff, and then it depends on which kind of tools that you're going to be invested in, and the onboarding cycles from there kind of vary, but it's definitely a critical aspect around that. And CICD, maybe one of you guys can talk about it. I know, Micah, you've done quite a bit on Panickar for sure.
Yeah, we've used Spinnaker a lot in the Kubernetes space, but so CICD, for me, we've actually gone really heavily into the CDK. We were a serverless framework shop, Terraform, but when CDK came out, it was a way for us to create kind of this seamless experience. We really focus on frictionless, right? So what we're actually doing now is what you want to do is look for repeatable patterns, and what we've done is we've taken the CDK and we're actually bundling up through like an inner source at Asurion project, JavaScript bundles that developers just npm install. I want CloudFront and I want an S3 bucket and I want this UI to go there. And then they can just npm install and then they run some npx command and off it goes. And it works the same, locally as it does within the pipeline. There's honestly, I think Eric said it best, pick a framework. I genuinely believe that CI/CD pipelines should be treated as products. Right? You should version them. People should understand what they're about. They should be documented. Okay. You need to provide visibility. And when you do that, a lot of it goes back to creating that culture of people talking about these things. So there's actually a ton to unpack there, but we have a question from Will in the chat I want to get to because I know we're about to have to hop off for the next talk. So a question in the chat from Will, is there any preferred mechanism criteria for determining if a logical component or microservice works best in a serverless environment versus a more traditional approach, such as basic EC2s, RDS, etc.? I have leveraged Cloudcraft to compare costs associated, but curious if there are any rules of thumb when predicting scalability. In other words, is less more in the cloud, or should services that aid scaling, like SQS, serverless in general, be added preemptively? Apologies for the broad question. I think that's a great question. And yep. Ramesh, if you don't mind, I'm gonna pick on you. Would you have any thoughts on that?
Yeah, no, definitely. I think because a lot of companies, as part of their modernization strategy, right, like they're breaking up these monoliths and going towards microservices. But this question often comes up, hey, is the serverless is the right fit, or shall I go for the traditional hosting model, right? Again, the answer is it depends. Again, but I will give you. But if you are looking for more prescriptive, right? So if your microservices really, like, again, this is my observation and my experience is, if it is heavily used microservice or function, right, which requires like a continuous compute and storage resources, right, containers would make perfect fit for running such microservices. But if these are all trigger based or event based or one-off functions that you are running, right, for cost implications point of view and also from ease of maintenance point of view, serverless is a great way to go and host those microservices, because you don't need really continuous resources, which is like containers, because underlying it is using compute, which is more cost prohibitive. In that case, serverless would make really, really good sense in that case. So it's a balance act really. But yeah, definitely I don't recommend EC2 based hosting for these microservices or any traditional based hosting. Definitely go for containers, and if not, serverless, right? But your first priority should be containers, especially for those microservice model, and which are being used by 24/7 kind of model. Yeah, containers would be the right fit. But if it is like need-based triggering or event-based triggering, then go with the serverless, not definitely EC2. For microservices, yeah. Unless
there is not EC2, right?
Yeah, not EC2, right?
And there are, ways to have the underlying compute of your containers managed through things like Fargate and other things. So you can still get some of the benefits of serverless with a container at the same time. I think that's important to mention. And what I like about this question is they call out SQS. If you're doing serverless, absolutely use queues, right? Use it, turn it into an event-driven model. If you can convert to an event-driven model, it's probably going to work very well for you, and doing that kind of data first. In some ways, serverless kind of turns things on their head a bit. And you sometimes have to re-ask yourself the question, does this still work the same way that it used to in a traditional model in serverless? And that affects things all over the board.
And also, I want to add one more thing, because a lot of companies, right, because when they think about serverless, a lot of people, especially they're worried about lock-in, right? Like with the vendor lock-in or something, right? But I think more and more these cloud platforms, right? Like they're coming up with the container support even in the serverless, really. Like, hey, make your Docker images, right? Hey, if you want to really not worry about the underlying infrastructure, go with serverless if you are comfortable, and you can use the same images actually like on the serverless, and then you can put them. Hey, if you think if it is cost prohibitive or whatever the reasons, you really want to run this as a container orchestration model using either like any of the Kubernetes orchestration services like EKS, AKS, or GKS, whatever, right? Whatever the cloud platform, right? Any KS, right? Yeah, you can use the same Docker images and put them in a real Docker, Kubernetes orchestration model to really scale up, scale down, or manage your containers. So I think now, the two worlds are coming together. So there is no real worry about the lock-ins or proprietary kind of deal. Especially even thinking about serverless. Yeah.
And you can do things like benefit from taking like Bottle Rocket, which is the OS used to run, these container workloads for serverless. You can put that in your EKS cluster, right? We're borrowing from serverless even when managing compute sometimes. Now, I know we're over, so I want to say thank you very much, Abhilash, and thank you, Ramesh, for your time today. Very insightful, great questions. We're going to hand it over to Yan Kui, who's going to cover GraphQL and serverless for social networks. So thanks again, everyone.
Thank you.
Thanks, Micah, for hosting.